Hey folks, let's go ahead and take a look at number 21. I have to solve this system of nonlinear equations, and there's a couple of ways to do this. You could opt to use elimination. I could see that route. If I was going to use elimination, I might multiply this entire equation by -25 just to knock out the y squareds. But I'm going to go ahead and do it a slightly different way. I'm going to go ahead and do substitution. And for substitution, for this particular problem, I'm going to solve y squared in this equation, and then I'm going to substitute that into the second equation. So if I want to solve for y squared, I'm going to move x minus 6 squared over to the other side through subtraction. And that's what you see here in this little box. I opted to try substitution. Again, you don't have to, but I did. So if y squared is 1 minus, and in parentheses, x minus 6 squared, I'm going to drop that right here. And that's what you see me doing here, right? So let me pull up the highlighter. And here is my y squared. And instead of writing y squared, I swapped it out with 1 minus, and again in parentheses, x minus 6 squared. Now I got to use PEMDAS for that. All right, so what I have to do is I have to square the x minus 6 first, right? So you have to think of x minus 6 times x minus 6. And when I FOIL that out, I'm going to get x squared minus 12x, plus 36. That's what you see here. Then I have to remember to distribute that negative to those three terms in that trinomial. And then again, that's what you see in this next line. And then I had to combine like terms, and I had a couple of constants, right? I had 1 and -36, and those will simplify here, and you can see -35. And then I still have some PEMDAS because now I need to distribute the 25 to everything in that trinomial. And so eventually, when I distribute all of that, I get to this line here, and I'm going to it made a circle for us. But when I take a look at that, again, I have a couple of like terms, right? I have the x squareds here, and then I have the constants here. But at the end of the day, when I see the x squareds, I know I have a quadratic equation. And if I have a quadratic equation, our two options are to set that equation equal to 0, and then either factor or use the quadratic formula. So I'm going to scooch this up a bit, and let me go ahead and just delete some of this because it looks a little crowded. All right, so I did go ahead and start combining those like terms, and you can see I set that equation equal to 0. And then I noticed that 16, 300, and 1100, they're all divisible by 4. So you see me factor that GCF of 4 out. And I personally, whether I'm using the quadratic formula or factoring, I like to have a lead positive on my quadratic term, so I took the negative with it. So when I get here, I went ahead and I tried to factor it, which I could. And again, if you want to use a quadratic formula, you're more than welcome to, right? And if I was going to use the quadratic formula, A would be 4, B would be -75, and C would equal 275. Or you could have used the quadratic formula here. You could have used it with A equaling -16, B equaling 300, C equaling a -1100. Regardless of which set of coefficients you use, when everything simplifies, you'll get the same answer. If you use these options, you'll have to simplify a little bit more on the back end. If you use these options after you factored out the GCF, you would have less simplification to do on the back end. I ultimately factored, all right, two terms that multiply to 4x squared were x and 4x. I could have tried 2x and 2x, but this is the one that unlocks. And then 275 is 5 and 55. So when I have my two linear factors, and again, let me go ahead and now just erase some of my scratch work because it gets crowded. You can see I get my two x coordinates. X is either 5 or 55 fourths. So then what I'm going to do is I'm going to take those two x values, right? I'm going to take 5 and 55 fourths and replace them or substitute them back into that y equation. Well, technically the y squared equation, and solve for y. And so when I do that, you can see me doing that each time, right? So instead of x here, I put the 5. And then again, instead of x, I put 55 fourths, and I crunched all of that out. And when you go ahead and, at that point, I'm going to use my calculator for the most part. Over here, I get y squared is 0, square root both sides, the plus or minus shows up. But plus or minus 0 is just 0 because 0 is neither positive nor negative. So here I get one ordered pair of 5, 0. And when I simplify this, I get y squared equaling a negative number. And when I try and square root both sides, yes, the plus or minus shows up, but it's not an unreal answer, right? Because if I wanted to be a little bit more precise, it'd be something like plus or minus square root of 59 and change 0625 I, right? I could take the I out, but it's imaginary. It's not a real solution. So there's going to be no additional points on these graphs where they intersect. So my only answer out of here is 5, 0. Okay, thanks so much, everyone. Bye.